Hello everyone, this is the solution for problem 5 in homework 2. So firstly, from the statement of the problem, we know that the probability of n customers, k customers, come in t minutes is equal to the exponential distribution with parameter lambda. It is e to the power of minus lambda t times lambda t to the power of k over k factorial. So this is the exponential distribution with parameter lambda. So for the first part of this problem, we want to solve the parameter lambda. So in the statement of the problem, we know that the probability of at least one customer arrives in 2 minutes is equal to 0.3. So look at the at least. If we directly solve it, it will be really hard because it means k is larger than 1. Then we will need the k equals 1 sum k equals n equals 1 to the infinity t equals 2. So it is really hard to compute because it has infinity terms. So then we can compute the converse of this event. So the converse of this event is nobody arrives. So at least one arrive, then the converse is nobody arrive. So the probability of 0 customer arrives in 2 minutes is equal to 0.7. 0.3. Then the probability of k equals 0, t equals 2 is equal to 0.7. So from the formula star, we will have e to the power of minus 2 lambda equals 0.7. Then lambda equals to minus 1 over 2 of the ln 0.7. So we successfully get the value of the parameter lambda. So for the second part, what we want is in 3 minutes nobody arrive. So in 3 minutes nobody arrive, then k equals 0 and t equals 3. So we want the probability of the exponential probability with parameter k equals 0 and t equals 3. So it is e to the power of minus 3 lambda times 3 lambda to the power of 0 factorial. So this part is equal to 1. So this is e to the power of minus 2 lambda to the power of 2 over 3. So it is 0.7 to the power of 3 over 2. Then we use the calculator, we will get it is equal to 0. Let me see. 0.5857. Okay, so we successfully solved the second part. So for the third part, we want that the probability of at least 2 customers arrive, it is k is larger than 2 with t equals 10, the probability of that. So if we directly solve it, it is really hard because it has infinity terms, same as the solution in problem 1. So we can also compute the converse of this event. So it is equal to 1 minus the sum of n equals 0 and 1 So I do not want the notation of summation because it only have two terms. So it is pk equals 0, t equals 10 minus the probability of k equals 1, t equals 10. So this is 1 minus e to the power of minus 10 lambda, and this is 10 lambda times e to the power minus 10 lambda. So simplify this formula for easy computation. It is 1 plus 0 lambda times e to the power of 10 lambda. So because lambda equals 1 over 2 ln 0.7 and e to the minus 2 lambda equals 0.7. So this one is equal to 1 minus 1 plus 5 ln. Also this is minus 5 ln 0.7 times 0.7 to the power of 5. So using the calculator we can get it is 0.45322. So we successfully solved the third part. The first part is really straightforward. What we need is in 1 minute exactly when customer arrives. So it is the probability of k equals 1 on the condition of t equals 1. So this is equal to lambda times e to the power of minus lambda. So it is minus 1 over 2 ln 0.7 times 0.7 to the power of 1 over 2, because 0.7 is e to the power of the square of this part. So we need to compute the square root of 0.7. So this is, by the calculator we can get it is 0.15. So the probability of exactly when customer arrive is 0.15.